Neptune is the last planet in our solar system where it all begins. The dominance of Kuiper Belt objects, a dark, dense part of space where even sunlight takes hours to reach. This extremely cold region is home to some mysterious objects that roam in the Kuiper Belt billions of kilometers away from us. But among them is a familiar name, Pluto, which is wandering in that dark world. Pluto has always attracted the attention of astronomers, and humans are so curious that they can go to any extent in search of their answers. Are we, the creatures living on this earth, the only ones floating in this universe? Is there no life anywhere else? These questions have always compelled humans to search for life beyond Earth. We humans have never lagged behind in searching for life, even in impossible places. The search for life on Pluto has taught us a lot, and we will continue to learn in the same way. But this search surprised the scientists a lot. NASA launched the New Horizons spacecraft to study Pluto, and in 2015, it passed close to Pluto. Then the evidence that NASA collected from Pluto is. At the same time, it was also hard to believe that Pluto could even compete with Europa and Titan. So what exactly did New Horizons send in its data that completely changed the way we all looked at Pluto? So I am your friend Shashi, and we have already set out on this journey, and Pluto appears to us like an active world. There are mountains here, passes, valleys, glaciers, where oceans of nitrogen are frozen. There is a thin, light and mist-filled atmosphere. But looking at it, it's hard to say if Pluto is really suitable for life. By the looks of it, Pluto doesn't seem suitable for life in any way. Here, there is suffocating carbon monoxide and third, liquid water. Yes, liquid water. From what we know about Pluto, we can say without any doubt that Pluto has an energy source. And astronomers knew this even before the New Horizons mission, that Pluto has two. Has been passing through, and this heat source is Pluto's dominant energy source. It provides Pluto with so much energy that it heats the rocks inside Pluto to their melting point, whether it is deriving it or not, just like we see in Earth's mid-ocean ridges. But it's completely clear that Pluto has an energy source. As for the second thing, for habitability, if we look at organic molecules, Pluto also has them. Its atmosphere has about 0.3% methane, and most importantly, New Horizons discovered that solar ultraviolet radiation is splitting these methane molecules into other hydrocarbon compounds like acetylene, ethylene, and ethene methane. So, this reddish material can also be seen on Pluto's surface. These are the particles of the same hydrocarbon haze which have settled down from its atmosphere. That's why at least organic molecules are present on Pluto's surface. They could help life develop and could be a reason for life to emerge. But it's not yet clear whether any such mechanism exists here, through which these organics could form underneath. They could reach the vast oceans where the other resources necessary for life would also be present. Studies done by astronomers on comets have shown that organic molecules are also found in objects of the outer solar system. Just like we have seen on Pluto, after this, to reach habitability, Pluto has to clear the last hurdle, which is confirming the presence of liquid water. As I told you earlier, radioactive decay inside Pluto releases a significant amount of energy, and on a geological timescale, it has released enough energy that the ice on Pluto could have melted several times. Even before the New Horizons mission, astronomers knew that there could be a liquid ocean beneath Pluto's surface, right beneath its thick ice shell, although there is no assurance that such an ocean actually exists inside Pluto, because many scientists believe that heat is being transferred slowly through convection by the insulating ice shell. Just like Earth's silicate mantle, this convecting shell removes heat from the interior very quickly. Because of this, it is possible that an ocean may never have formed beneath Pluto's surface. Therefore, this theory alone does not confirm whether oceans actually exist on Pluto or not. To find this out, we might need spacecraft observations. So, is there really an ocean on Pluto? We have 3 lines of evidence that point towards the possibility of an ocean beneath Pluto's surface. The first evidence comes from observing the subsurface geology of the dwarf planet Pluto. By closely observing Pluto's surface, we found that there are very large cracks and fractures that have scarred its surface. These faults, some of which pass through old impact craters, extend deep into Pluto's surface. This indicates that a global expansion has occurred on Pluto. The only reason for such expansion throughout the planet's interior could be the freezing of its subsurface oceans. We know that when water freezes, it turns into solid ice. The molecules of water align in a pattern, and the volume of that water increases after freezing. In the same way, it is possible that inside Pluto, the water and then later that pressure must have exceeded a certain limit and started erupting onto Pluto's surface, which scientists call cryovolcanism. Active cryovolcanic eruptions can also be seen on Saturn's moon Enceladus, but on Pluto we have found very little evidence of this. Between 2 large structures, a mysterious deep pit rises upward. Its edges suggest it could be a cryovolcano, but this alone was not enough to convince the New Horizons team. Then no one will accept the surface either, because the geological evidence here doesn't point to any single explanation, and both the fracturing and the cryovolcanoes are inconsistent with that idea. As the scientist is saying, there was an ocean beneath Pluto and it gradually froze. These things don't really match up. The second line of evidence is a feature of Pluto that Pluto doesn't actually have, but scientists believe that Pluto should have it, and this really surprises scientists. When 2 bodies like Earth and the Moon, or Saturn and its moon Ioctus, are involved. When moons orbit a planet, due to gravitational interaction, their equators appear more bulged out compared to their poles. This is also called bulging. This equator bulge forms when, in the past, the moon used to spin rapidly, and that bulging gradually becomes permanent over time. This is also the case with Saturn's moon Ioctus, and it can be seen in every body that spins very fast. Scientists believe that Pluto should also have such an equatorial bulge, because Pluto must have spun quite fast in its early days, but over time its speed must have decreased. So the bulge that must have formed on Pluto due to its rotation should be present on Pluto, but New Horizons has not detected any such bulge on Pluto. So scientists think that this is only possible if a subsurface ocean has formed beneath Pluto's surface and the ice shell on its surface was not strong enough to support that bulge, causing it to collapse. And this is a possible explanation for the presence of an ocean deep inside Pluto. The last line of evidence for the presence of an ocean on Pluto is the most complicated and also the strangest. It starts with the largest bright basin on Pluto's surface, Sputnik Planitia. This entire basin area is so bright because it is covered with frozen nitrogen ice which fills the whole basin. This ice comes from the nitrogen glacier from where it flows and spreads to the surrounding areas. There is another amazing fact related to Sputnik Planitia regarding its location. This region is in the completely opposite direction from the side of Pluto that always faces its moon, Charon. Let me tell you that Pluto and Charon are tidally locked to each other, so the same face of each always faces the other. So in such a case, if we add some extra mass to that planet, like a big mountain, then Pluto will rotate in this way until that extra mass reaches Sputnik Planitia. Scientists call this process true polar wander or TPW. Because of TPW, Pluto's surface gets distorted when some extra mass is added to it, and due to this, we can see expansion, fractures, and many other features on Pluto's surface. For scientists, the location of Sputnik Planitia makes perfect sense. But if it behaves like an extra mass, the question now is, how can this basin behave like an extra mass? After all, it's like a crater on Pluto's surface. So the explanation could be something like this. As soon as nitrogen ice flows from the glacier and fills this crater, it becomes a little denser than water ice. And in this way, this basin contributes a little to the extra mass, but the contribution of ice is very small. Another explanation is that the reservoir of water ice beneath it melted from below the surface. The ice shell beneath it became thinner and melted, turning into liquid water, so that water acted like excess mass. If we combine nitrogen and the thin ice shell, this excess mass is enough to produce TPW. So this explanation also points towards the presence of a water ocean inside Pluto. However, none of these lines of evidence are bulletproof. But if we look at all of these together, the possibility increases many times that Pluto could also have water oceans. The events happening there, the conditions there, are in favor of the idea that there must be some water ocean there. To prove habitability on Pluto, we needed three things. First, an energy source, which Pluto has. Second, organic molecules, which are abundant on Pluto. And third, water, the search for which has not yet reached any conclusion. So exactly how will we confirm water oceans on Pluto? Because this is the last link to proving habitability on Pluto. For the past 2 decades, scientists have been using several techniques to search for subsurface oceans on ice bodies. But unfortunately, the best techniques we use among these cannot be used on Pluto. The first technique requires a background magnetic field which induces currents in the body's salty water ocean, and then scientists can study the secondary magnetic field created by this induced current to confirm the subsurface ocean. This technique works very well on Jupiter and its moons. But in the case of Pluto, there is no large background magnetic field here that can produce such signals. The second technique is to measure the size of the tides formed on the body. The larger the tides, the higher the chances of there being a water ocean. But here too, Pluto and Charon always keep the same face towards each other, so no effective tides are produced. So both these methods don't work on Pluto. Because of this, confirming the presence of an ocean on Pluto is a tough task, and for now, the search for water on Pluto remains a mystery. So now the question is, how habitable is Pluto really? Can we hope for life here? So look, Pluto is a small planet orbiting in the darkness billions of kilometers away. Although its interior is warm, organic molecules are also found on it, and lines of evidence suggest the possibility of a subsurface ocean here. This makes us think that this small world fulfills the basic requirements for habitability, but that doesn't mean at all that Pluto is a paradise for life to develop. That's not the case because we don't know how much these three things, energy, organic molecules, and water, are able to interact with each other. However, it's possible that the rocky core is arranged properly. But if organic molecules are only found in the atmosphere, then Pluto would need a mechanism for these organic molecules to reach its interior so that life could begin in its earliest form. But our evidence suggests that Pluto's shell is cold and rigid, and there probably isn't any mechanism that would allow these organic molecules to reach its subsurface ocean. That means Pluto has all the ingredients, but because it is isolated, there is a threat hanging over life and habitability there, and that's why Pluto isn't as tempting a target for us as Europa and Enceladus, where the ice shells are moving and thin. But at the same time, Pluto could be a better option than other large moons like Ganymede and Titan, where thick and high pressure ice layers break the connection between the ocean and the heat source. Pluto generates so much heat that it can comfortably sustain subsurface oceans for billions of years. Apart from this, the ongoing activity on Pluto was surprising the entire scientific community. Everyone wanted to know what exactly was happening on Pluto that was making it so mysterious. It became important for NASA to study Pluto as well, because Pluto played a crucial role in the formation process of our solar system. They planned a mission for Pluto, which performed a flyby near Pluto on July 14, 2015. And the data we received from this mission was not easy for everyone to digest. It was surprising how such a small planet so far from the Sun could hide so many secrets within itself. Clyde Tombaugh was the person who discovered Pluto on February 18, 1930, and with this discovery, a series of mysteries also began. For the next 58 years or so, Pluto, its atmosphere, and the activities happening there remained a mystery for us humans. But then, something special happened in 1988. By using the stellar occultation process, scientists discovered the atmosphere on this planet. People had been waiting for this moment for a long time. Stellar occultation is a phenomenon. When any planet or body passes in front of a bright star, the gradual dimming of that star's light reveals information about the atmosphere, the planet's size, rings, and much more. When Pluto's stellar occultation occurred in 1988, scientists discovered Pluto's atmosphere. People had been speculating about it for decades. If Pluto didn't have an atmosphere, the light coming from the star would have been suddenly blocked as Pluto passed in front of it. But when this occultation happened, the starlight gradually dimmed, and because of the starlight, Pluto's atmosphere was almost glowing. As the atmosphere's density increased from space to Pluto's surface, it gradually blocked the starlight. By studying the collected data and patterns, scientists discovered the layers of its atmosphere, and they also identified elements present in it, such as nitrogen, methane, carbon monoxide, and other gases which cover the surface of this planet. When astronomers graphed the light data, another conclusion emerged that the light did not penetrate Pluto's atmosphere all the way to the surface. This also indicated the presence of clouds, haze, and similar phenomena there which were blocking the starlight. Apart from this, astronomers noticed certain symmetries in the light curve which confirmed that this dimming was indeed due to the atmosphere. And this is how we found out that Pluto also has a blanket of gases around it, which we call an atmosphere. Now, the existence of an atmosphere on Pluto was completely confirmed. Now astronomers wanted to know about the temperature changes happening in the atmosphere of this small mysterious body, which occur during its 248-year orbital period. Let me tell you that Pluto completes one orbit around the Sun in a time equal to 248 Earth years. Its orbit is highly elliptical, so much so that when it is at perihelion, that is, at its closest distance to the Sun, it is about 30 astronomical units away from the Sun. Let me tell you that 1 astronomical unit is considered to be the distance between our Earth and the Sun. And when Pluto is farthest from the Sun, its distance becomes about 50 astronomical units, which means almost 50 times the distance between the Sun and our Earth. But this difference of 20 astronomical units between the closest and farthest points in its orbit gives rise to interesting chemistry in Pluto's atmosphere and on its surface. We know that Pluto is a rocky body, but it is covered in ice. When it comes closer to the sun then, the temperature of its surface rises up to minus 220 degrees Celsius, and because of this, the frozen ice on its surface sublimates and goes into its atmosphere. Sublimation is a process in which any substance in solid form changes directly into gas without turning into liquid form. So, the nitrogen ice frozen on Pluto turns directly into molecular nitrogen when the temperature increases. Earlier, astronomers believed that as Pluto moves away from the sun, its atmosphere must freeze, and after going below minus 240 degrees Celsius, all the gases must freeze. In this way, one day Pluto's atmosphere will collapse. But observations forced scientists to rethink because the results of the observations were saying that Pluto's atmosphere is not collapsing. In fact, it is getting thicker. This is possible because of its elliptical orbit around the sun. Apart from this, another interesting fact about Pluto's atmosphere is that it evolves quickly. Researchers have claimed that the density of carbon monoxide in Pluto's atmosphere has increased rapidly over the past few decades. But it was also found that carbon monoxide extends more than 300 kilometers above this planet. Those molecules are carried away by the solar wind. It is completely cold and frozen, but this is where the story of Pluto's atmospheric composition begins. It is inert, completely cold and frozen. But this is where the story of Pluto's atmospheric composition becomes interesting. Thanks to methane, which causes global warming on Pluto. Yes, global warming on Pluto. Methane is a greenhouse gas that absorbs the infrared radiation coming from the sun. And in this way, Pluto's temperature keeps increasing continuously. Because of methane, there is a temperature gradient on Pluto, in which Pluto's temperature increases up to minus 173 degrees Celsius with altitude. In the same way, a pressure gradient is also at work here. The pressure on its surface remains up to 20 microbars, and with height, it goes down to 3 microbars. After that, it keeps decreasing continuously, up to the vacuum of space. From here, the interaction of hot and cold air, and higher and lower. But the formation of winds is not due to the vertical temperature and pressure gradient, but rather due to the horizontal temperature and pressure gradient. Now, on Pluto, there are also changes in temperature and pressure in the horizontal direction. For example, due to the sun's uneven heating or because mountains block the sun's heat, there is a difference in temperature. Apart from this, due to the uneven distribution of nitrogen on the surface, there are also changes in pressure. And because of these horizontal gradient changes, very strong winds blow on Pluto, and due to these winds, the ice gets redistributed all over Pluto. SETI Institute scientist Angela conducted research this which can reduce the speed of these winds. That's why it is believed that such high wind speeds are possible on Pluto. This is exactly like our Earth, where the speed of winds increases with altitude. But scientists are surprised that on Pluto, this speed is much higher than expected. The mystery of winds on Pluto still remains unsolved, but solar winds make this mystery even more interesting. Even though Pluto is at an average distance of 6 billion kilometers, solar winds still reach its atmosphere. However, by the time they reach Pluto, they become 1,000 times less dense than they are on Earth. Both solar winds and UV radiation play a major role in Pluto's atmosphere. Scientists believe that due to ionized UV photons, the atmospheric gases of Pluto also become ionized, and then they are picked up and carried away by the sun's interplanetary magnetic field. And in this way, solar winds are causing Pluto's atmosphere to leak into space, but because of this action, the solar winds themselves slow down. The laws of physics say that momentum, that is, the product of moving mass and velocity, is always conserved in a system. For this to happen, the velocity term has to go down, but it's clear that extra mass is being added to the system. That's why, to conserve momentum, the speed or velocity decreases accordingly. This mysterious process keeps happening in its atmosphere all the time. As we mentioned earlier, there are also a lot of clouds and fog present in its atmosphere. Molecular nitrogen, carbon monoxide, and methane are the main ingredients of its atmosphere. On Earth, we call this layer the troposphere, where the temperature decreases as we go higher, causing the water molecules present in the sky to become supersaturated and form clouds. After this, in the stratosphere, the temperature starts increasing again with altitude. On Pluto, if we see, the troposphere is not very thick. In fact, it is only 1 or 2 kilometers thick. That means on Pluto, clouds form very close to the surface. Now, when clouds are forming, there should also be rain. And on Pluto, it snows. But this is not at all like the normal snow that falls on Earth. It's not just different in composition, it's also different because of Pluto's atmosphere. Earth has a very dense and thick atmosphere which is filled with many water molecules. But in Pluto's atmosphere, this content is very low. The particles are very fine, their size is in microns. So, these don't form snowflakes like on Earth, but still, the snow here follows regular hexagonal symmetry. These are like the baby versions of Earth's snowflakes, baby snowflakes. Watching only snow fall from the sky isn't enough for a space lover. There's a different kind of joy in watching auroras in the night sky. Astronomers believe that Pluto has a small ionosphere and also possesses a weak magnetic field. Because of this, auroras can also be seen on Pluto. However, due to its thin atmosphere, the chances are quite low. Pluto's magnetic field is still a mystery for us, and without a magnetic field, we can't even imagine auroras. So, the concept of auroras on Pluto also depends on whether other factors are present or not for now. However, the mysteries you are about to hear have made Pluto's. We talked earlier about Pluto's atmosphere leaking, but a surprising discovery shocked astronomers, and that discovery is the volcanic eruption of cryovolcanic materials like water, ammonia, and methane. They were surprised that even after the leakage, the amount of gases in Pluto's atmosphere kept increasing. Even in the past few decades, Pluto's atmosphere has become thicker, and the reason for that is also these cryovolcanoes. In a study conducted by astronomers, there are also possibilities of cryovolcanoes being present there. However, we have data that tells us so much about Pluto's atmosphere. The gases released from cryovolcanoes go into its atmosphere, and that's why the amount of gases in Pluto's atmosphere keeps increasing continuously. And that's the reason why Pluto's atmosphere is becoming thicker. These volcanoes tell us that there are still activities happening inside Pluto, which means Pluto is still alive. There was a time when Pluto was considered a planet. But in 2006, the International Astronomical Union took away Pluto's status as a planet. Just hearing about the colonization of Pluto sounds strange, although colonizing Mars and the Moon is not easy either. Still, we have many plans to colonize them, which will be implemented in the future. But colonizing Pluto is not going to be easy. When we think about it, we will be faced with a mountain of challenges and questions. And here, we will try to find solutions to these questions and challenges, even if those solutions are hypothetical. If we want to travel to another planet using today's technology, the closest one we will find is Mars. To reach there, we will have to cover a distance of 54 million kilometers, and with today's technology, it will take us about 7 months to cover this distance. Now just think, it takes us months to reach our neighboring planets. So imagine how much time it would take us to reach that dwarf planet, whose distance is not in millions of kilometers, but in billions of kilometers. Yes, you heard it right. 5.3732 billion kilometers is the distance. New Horizons reached Pluto on July 14, 2015. It took more than 9 years to reach Pluto. Now, in the past few years, space technology has developed a lot compared to before. But even now, it still takes us 8 to 9 years to reach the last few planets of the solar system. Forget about space missions, even the fastest thing in the universe, that is light, also can't reach there easily. The light coming from the sun takes about 5.5 hours to reach Pluto. Now, colonization can't be completed in just one mission. Whenever we talk about colonizing a planet, the first thing we do is build places suitable for humans to live there. These places could be constructions made on that planet, or they could be space stations orbiting the planet. After building the place, we arrange some essential resources to keep the human population alive. This can't be the work of just one space mission. The work of colonizing Pluto will continue for several decades, and it will require technology, resources, and a lot of money. First of all, we will have to develop technology that allows us to survive on this planet for a long time. We will have to make our astronaut suit technology even more advanced, and if we want to survive on Pluto, we might have to make the astronaut suit a part of our body. This sounds very strange and even a bit scary, but the real scary thing is yet to come. There is a small town in Russia called Oymyakon where the temperature drops to minus 50 degrees Celsius. People live here too, but their lives are not that easy. Such low temperatures have a very bad effect on the human body. Now just imagine if this temperature goes even further into the negatives. If we are able to develop the ability to keep our bodies alive, we would be challenging the laws of biology here. If we have to fight Pluto's cold temperatures, then either we will have to terraform this entire dwarf planet, or we will have to build some kind of base where the temperature is higher than the rest of the planet, at least high enough that we can keep ourselves alive. The very first challenge of going to another planet is survival. If our bodies can survive and function properly on Pluto or any other planet for a significant amount of time, only then can we think about building a settlement there. Because for now, this is all just hypothetical. Let's also assume that we have developed such technology that can keep our bodies alive in Pluto's environment for a long time. Here, our first challenge, which is survival, we have achieved a hypothetical victory over it. What will be the next step? Next, we will have to start building settlements on this planet. We will have to start construction. Now, even here, we have two big challenges ahead of us. First of all, the surface of this planet, and second, gravity. These are the two challenges we will face. It will be difficult for any construction to stay on the surface of this planet. Forget construction, even we ourselves will find it hard to stay on this planet because its gravity is only 8% compared to Earth's. If your weight is 50 kilos on Pluto, you would feel like you only weigh 4 kilos. Apart from gravity, the second challenge we will face is its surface. Its surface is made up of 98% nitrogen ice. It won't be easy to build on such a surface with such low gravity. How will a base be constructed for humans to live in such an environment? We might find this out in the future when space exploration and human technology have developed much further. But for now, doing something like this would be considered science fiction. But if somehow a base is established on Pluto, it would be a major milestone in space exploration. Because in that case, Pluto would open a path for our interstellar exploration. Maybe in the future, we will be able to establish our observatories on Pluto itself, which will help us understand the Kuiper Belt and the worlds beyond it in a better way. New Horizons itself is a long story. From 1989 to 2003, it took almost 14 years to finalize this mission. Dozens of mission concepts, proposal after proposal, and on top of that, funding cuts. But finally, after a tough competition between rival teams, NASA chose its Pluto flyby mission, that is New Horizons. There was very little time. If they had to reach Pluto with less fuel, then using Jupiter's gravity assist was necessary. In 2006, New Horizons was finally launched. After this, New Horizons traveled through the darkness of space for almost 9.5 years and finally reached Pluto and its 5 moons. It had to be used. After this, two was launched. Near 5 moons. It's necessary to use of its 5 moons. A hidden ocean of water beneath its surface. For scientists, getting so much from one mission was nothing short of a treasure. Besides Pluto, its moons also did not disappoint. New Horizons data revealed that Pluto's moon Charon was formed due to a massive collision between Pluto and another dwarf planet in the past. Besides this, Charon's surface is mysteriously reflective, but its polar caps are completely dark, which could be because methane from there. Has escaped. In fact, now a new mission is needed to study Pluto in more depth and to solve the mysteries related to it. Now the biggest question is, why do we need another mission to Pluto even after New Horizons? It made a close pass, and during this time, New Horizons was only able to properly map about 40% of Pluto's surface, and it was the same case with Charon as well. Apart from this, we know even less about Pluto's other 4 moons. Space keeps changing, but during New Horizons flyby, we were only able to observe Pluto for about 24 hours, which gave us a great snapshot of the planet, but it didn't allow us to study the daily changes or seasonal. What makes us think about new missions to Pluto are the new and advanced instruments. We know that the new questions arising from New Horizons data can be solved using advanced instruments. If we send an orbiter mission to Pluto, we can use radar to investigate deep inside its glaciers and find out how deep they are. A mass spectrometer lets us analyze the atmosphere's composition and its elements. We can also find out where the glaciers are getting their power from, whether ancient ice volcanoes inside it are still active, whether this planet is alive, meaning is its core still active, or is it dead, or has it frozen solid from the cold. Without a magnetometer, this cannot be determined, and without an orbiter, it is not possible. And finally, to map Pluto's poles in the dark, we will need advanced and active instruments like LiDAR. It should be designed for years of operation, sending us data week after week and continuously keeping an eye on Pluto and its moons so we can observe their geology and atmosphere as they evolve. Mission. Research was conducted on how to put an orbiter into orbit around Pluto. The research found that to launch a spacecraft on the scale of New Horizons with advanced instruments, a new Saturn V class launch vehicle would be needed. It would be possible what attributes the spacecraft would have and how the spacecraft would be sent from Earth to Pluto. The biggest breakthrough that came from this study was the solution to the propulsion system requirement for reaching Pluto. Initially, the researchers added a lot of propellant mass to the spacecraft, but later they found that virtually the propellant needed to explore Pluto and its moons could be eliminated by performing a close flyby of Pluto's largest moon, Charon, that is, by using repeated gravity assists. This is exactly like the missions sent to explore Saturn. It's like the Cassini mission, which was sent to study Saturn and its moons. After designing the mission, scientists created its timeline like this. The mission will be launched in December 2028. In December 2030, it will fly by Jupiter and increase its speed using a gravitational slingshot. In 2046, it will use braking to enter Pluto's orbit, and the mission will be completed in the year 2069. We could reach Pluto even faster if we had a high-power nuclear system available to increase the braking thrust. This would allow the spacecraft to slow down quickly when it reaches Pluto, but for now, slow trajectories are the only feasible option for us. This mission will study Pluto and its moons for 2 years. The braking maneuver will be completed using Charon's gravitational assist, and after that, the spacecraft will be placed in Pluto's orbit. The orbit around the planet will last for a few weeks, and during this close flyby, it will explore each of Pluto's moons. Dozens of such flybys will be conducted, and more than 30 close flybys of Charon alone have been planned. This will allow the spacecraft to map Pluto in both equatorial and polar orbits, and it will also be able to collect samples from its upper atmosphere. Although this mission will last for a long time, the spacecraft will have to complete all its objectives within the set period of 2 years. The spacecraft orbiter will have most of the capabilities we need, similar to New Horizons, but due to the flight system, the orbiter's payload mass will be almost double the weight of a full-fledged spacecraft system, along with the electrical and chemical propulsion systems will be around 2,349 kilograms. These are the current estimates. However, the launch vehicle chosen by the scientists can launch up to 30% more payload into space than this. Most of the capabilities of the Bali orbiter will be similar to New Horizons, but there will be some differences as well. And here we will talk about the 3 primary differences between the proposed orbiter and New Horizons. The first is that the orbiter will need more onboard fuel because during its mission period, it will have to make continuous corrections to its orbit. In addition, fuel will also be needed to continuously operate the reaction wheels to stay stable at one point in the orbit, whereas in New Horizons, the amount of fuel was quite low. The second thing is the need for larger onboard data storage. New Horizons was sent with 16 GB of onboard data storage, whereas the orbiter will have to work more frequently, so reliable data storage becomes necessary. The third and biggest change will be more. Regarding a capable communication system, the communication system that was designed to return the data from New Horizons' single flyby mission. It completed its work in 16 months, which is not useful for an orbiter, as an orbiter will have to send the collected data to Earth every 15 to 30 days. For that, a much bigger dish, antenna, and transmitter will be needed, which will have to be about 10 times more powerful than New Horizons. Along with this, it will be capable of removing background noise from its images and spectra using its software. And fortunately, we don't need to develop any new technology to make all these changes. This mission is feasible with our existing technology. Before 2015, that is, before the exploration of Pluto, most planetary scientists thought that after New Horizons, a natural follow-up flyby mission should be done. This would allow all the dwarf planets in the Kuiper Belt to be explored as well. In this way, we can explore the diversity of dwarf planets in the same way that the Mariner, Pioneer, and Voyager missions carried out their explorations. They first studied the terrestrial planets and then all the gas giants. However, after witnessing the spectacular complexity of the Pluto system, scientists are now confused because there is so much to study in the Kuiper Belt, dwarf planets, and planetary bodies. And several groups of scientists are arguing among themselves that only Pluto should be studied in depth. By sending an orbiter mission, some communities are in favor of this, while others believe that a flyby mission like New Horizons should be conducted so that we can study more than one Kuiper Belt object like Pluto. In this sequence, the scientists' research team got another big breakthrough that with the Pluto orbiter mission, we can accomplish both tasks. We can also do a deep study of Pluto and, by going wide into the Kuiper Belt, explore other bodies as well. To combine both these missions into a single mission at an affordable cost, we need to look at the pros and cons on both sides. This will be like a tug of war. Scientists have called the result of going wide in the Kuiper Belt to study other dwarf planets and going deep to study the Pluto system, all in one concept, the gold standard Pluto Kuiper Belt Exploration Mission. Now, what is this new term, the gold standard? Does the game-changing gold standard mission work like this? First, there will be an orbiter tour of Pluto, and Pluto will be studied deeply. After that, by doing a gravity assist flyby of Pluto's moon Charon, the orbiter will be taken out of Pluto's system and sent further into the Kuiper Belt. That too without using any propulsion. After that, using the already existing technological capabilities, which NASA has already used in its Dawn mission, the spacecraft will use the electrical propulsion system to explore and study more than half a dozen small objects in the Kuiper Belt. This will also include several dwarf planets. In fact, in many scenarios, the Dawn propulsion system can be used to take the Pluto orbiter out of the orbit of one dwarf planet and use it for another orbital mission. This technology could truly prove to be game-changing for this mission. The breakthroughs from this research have ended the debate over whether the next exploration mission should be a flyby mission like New Horizons or a Pluto orbiter mission. It's pointless to debate this because a single mission can accomplish both tasks. Currently, no major space agency has planned such a mission, but it's possible that it could be launched in the final years of the 2020s or 2030s. This will have a major impact in the field of planetary science studies. Our exploration of planets, planetesimal formation, ocean worlds, exotic atmospheres, how dwarf planets work, and even astrobiology will expand. This mission will prove to be a major milestone in space exploration, and perhaps it will be remembered for much longer than Voyager. This will allow us to explore the alien worlds of our own solar system. Friends, do you want to witness such a mission in your lifetime? And what are your thoughts on this kind of mission? Please let us know in the comment section. Friends, how did you like this video? If you liked the video, please like it and share it with your friends. For more informative videos like this, make sure to subscribe to the channel and enable the bell notification. Friends, we'll meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.